Okay, so this session is called GraphQL Distilled for Java developers. So my name is Kito. I am the principal consultant at Virtua, where we do training, consulting, mentoring, architecture, etc. for both front-end and back-end development. So everything from Angular, React, some mobile work to web services, Jakarta EE, all sorts of fun stuff like that, and also cloud platforms as well. I'm a Java champion. I've been involved in several Java community process expert groups back in the day, like CDI, JSF, Portlets, etc. I'm a member of the Jakarta EE Guardian Leadership Council and a Google Developer Expert in Web Technologies. And if you like podcasts, I encourage you to check out the Stacked podcast, which is a podcast I do every month or so with me and a couple other, about 3 other excellent co-hosts, 2 of which are also Java champions. And we basically talk about enterprise development, front-end development, back-end development, and then also just we interview lots of people as well. So check that out if you like podcasts. All right, so that's my story. I would love it if people in the audience could tell me a little bit about your familiarity with GraphQL and like if you've used it before and in what environments. So if you could just throw that in the chat, I'd appreciate it. It always helps me to get a sense of like, you know, the audience before we get into the chat. All right, we've got 1 complete noob. Okay. All right, so we've got some noobs. I'm assuming most of you have worked with REST. Okay. Okay, so we've got a few noobs, which is great. Okay. All right, so with that, let me just jump right in. So what is GraphQL? It is essentially just another approach to client-server communication. And, you know, ever since the old days where I remember working on apps where, you know, it was like a Windows fat client, they used to say. Now, of course, we have fat clients again, but and, you know, it would be client server. It would talk, you know, from the app on your desktop to a database somewhere else, right? We've been doing this for a long time. So REST was one approach which took on, became quite popular, and GraphQL is just another way to do the same thing. So on the left here, we have a query. So it's a very simple GraphQL query that says, you know, give me a hero and give me the name property of the hero. And on the right is the response. Gives you the hero back with the name R2D2. So that's basically the simple premise. You basically communicate in terms of queries, not necessarily in terms of endpoints. So every GraphQL app usually just has one endpoint, which takes GraphQL requests. So it's a very, very different mechanism or different protocol for working with the client-server communication. So obviously, it does not use REST. And it actually was created by Facebook back in 2012. So if you're hating on Facebook, they have done some good things in the past. They gave us GraphQL and React if you like React, and they also gave us some other stuff as well. So it came out in 2012, and it makes sense because if you think about what Facebook is, it's a huge social graph, right? So they wanted a better way to represent their data and send it back and forth to the server. It was open source in 2015, and the GraphQL Foundation was started in 2017. And it's really taken off since then. Lots of different companies have worked with it. And of course, its usage is growing. Probably one of the biggest ones is Netflix, but also GitHub, Lyft, Twitter, etc. And one place to go, there's a graphql.org site, great place to go if you just want to get a handle on things, because it's essentially the main site. All right, so that's nice. There's a different way to do client-server communication, but why bother, right? So let's first of all talk about some of the benefits. It's a little bit simpler to use than REST in some ways because there's a single consolidated dynamic endpoint. So as opposed to having to create a new endpoint for every single use case, you basically are working with the query, basically with like an API, but it's a little more nuanced than that. Basically, you're working with the structure of the data. There's also support for subscriptions, which to me is one of the biggest benefits. And that is the idea that you can say, okay, for this particular sort of like a query, but you basically say, I want to create a subscription and I want to be notified of changes to this particular data. And basically those changes are pushed back to you. So it allows you to have really dynamic applications. And it's a feature which isn't really supported by REST. So that's a really nice feature. Also, it has a defined data format. So unlike REST, where the schema of your API is completely up to you, the data in GraphQL API is defined by a schema. And so when you design a GraphQL API, you define a schema, and that schema is typed, which is really nice. So it sort of limits a lot of the errors that people can create. Another main benefit is that the client decides what data it wants, and the server decides where to get it. So as opposed to the client having to remember this particular endpoint returns me which data, basically it can look at an API and say, okay, this is how I can query the data. I may only want some of these fields. I may not need them all. And then the server decides where to get it. Now, in a very simple microservice or traditional microservice, that's still going to come from a database. But it could come from anywhere, right? Because it's just an API. So you'll find GraphQL used a lot to integrate disparate services. So let's say you've got 20 different REST services, but you want to provide a unified way to query them. You can do so with GraphQL. So you'll find that as a very common use case as well. So let's talk about some of the drawbacks of REST. And these are some of the things that GraphQL is trying to handle, right? So the endpoint decides what data is returned, which is good in some ways, but it's also bad in the sense that you don't really have a lot of control. Like, I think a lot of us have written a REST endpoint and then find out that the client needs more data, and then you have to add another parameter to it or create another endpoint that's similar but kind of different. And the problem is that you may return more data than the client actually wants. So let's say you return, a person object and then all of the properties of the person and then, all the people they know and all that kind of stuff. Well, maybe the client only wants to know the person's name. Well, then you have to write another endpoint or change your endpoint to support that feature. Whereas with GraphQL, the client can just say, hey, give me the person's name up front. So it makes things a little bit easier in that way. Sometimes with REST endpoints also, you find that you need to call many different endpoints in order to get all of your data back. If you have a well-designed GraphQL API, you can actually have, one call the client has to make. Now, maybe the server has to make some other calls to get the data, but at least the client API is simpler. With REST, there's no specific data format. That really depends on what you come up with, which is good and bad. And of course, there's no push standard as part of REST. And that, to me, that's, again, a big selling point for GraphQL. Okay, so let's start with a demo. So like a REST, you can use any sort of tool to just test out a GraphQL API. You could use Curl. Postman has support for it, but it's not the best, at least last time I checked. So I've been using a little tool called Altair. So let me pull that up. Okay, so this is Altair. It has an Electron version you can install locally, but you can also just run it in the browser. And like Postman, you can have collections and stuff like that. So It looks like I've got two, and I will delete this one. I think that's the one I want. Okay, so let's start out with a very basic query. Okay. So I'm actually going to be talking to the GitHub API. GitHub has a really extensive GraphQL API, which supersedes their REST API. And I want to find all of the issues from the prime faces repository. If you're familiar with JSF, you know about prime faces, but it's just a component library. And I want to filter by the open ones. I want the first 50. So I can do this query and I can get the result back. Okay. So now I've got data coming back, and you see I've got a repository, the name, I've got issues, and these are edges, which are essentially nodes. You don't have to design your API like this, but this is a common way to do it with sort of a graph or tree-like structure. So we've got issues, and then these are all the issues, right? So that's what I can get back here. Now I could decide that, well, I'll look at something else in a second there. But actually, as an example, I said before you could decide what data you want, right? So let's say I wanted to get all the repository names, but I didn't care about the issues, right? I could just do this. Okay. Now, of course, in this query, there's only one repository, right? But you know, if I didn't owner of, let's see, AWS, so they own more. Okay, maybe I know Google. Okay. Oh yeah, the name is here, right? If I did this, let's see how many repositories are owned by Google. The name is required. Okay. Anyways, but I can basically change my query to match sort of what I want to get back. And what's happening here is nothing fancy. We look at the request. So I'll run my query again. There's, you see it's one endpoint called GraphQL for all of GitHub. Okay. And the payload I send is this. So I'm sending an operation name, and then I'm sending the query, which is that query that we saw. And then there are variables, which I'll talk about in a minute. So basically, it's just a normal HTTP request with a specific format. So every request is going to look like this for a query, at least. And the response, as we saw, is just ordinary JSON. But again, it has this this structure where the first property is always going to be data. And then you'll get your actual data back. And there can be other properties too, which we'll see. Okay. So pretty straightforward. Okay, so here's another query. All right, so this gives us all of the repos with GraphQL and Java in them. So that we've got a decent number here. So how to GraphQL, QuickType, GraphQL Java, etc. I'll talk more about different GraphQL implementations later. But so there's a lot of repos that we get back here. And again, as an example, I'd get the name, right? The Stargazer account. You know, I could decide that I don't want the name or I don't want the Stargazer account, right? And I can get back just the names with owners. So I can decide what data I want to come back. And this helps with network, the amount of data being sent over the network as well, which is nice. All right, so here's another one. And this just does something a little bit different. So this is saying that we're doing the query for GraphQL, right? We want to find all the issues. Basically what we're doing is when we get a node back, a node is a generic or basically sort of a super type essentially. So we're basically saying, you know, for issues that we get back, we use these types, use these properties. So basically in situations where you can get multiple types back, you can basically decide which types you want back and specify properties from those types. So here we've got edges and we get back title, body, node, etc. Okay. So this is a very simple example. Now, you saw before that I had sent a request out, and there were some variables being sent, but the value was null or empty. Let's look at variables. So variables, Altair complains about some things here. Variables allow you to basically say, here's my query, but I want to parameterize it. So down here, the query is circuit breaker. So I have a basic search query for repositories, and basically this just allows me to change what I'm searching for as a parameter. And in the client code, whether the client is Java or JavaScript or something else, you can basically have that query defined and then pass in the parameter when you send it. So here I'm going to run this query. Okay, and we get back circuit breakers. And if I look at the raw data, do that request again. Okay, you'll see that now we've got in the payload this variable being sent in. So the query is sent in as is, but the variable is sent in separately. Okay, so it's a pretty handy feature for parameterizing things. Another feature are fragments, or is fragments. Okay, so here, as I said before, you can specify the properties on the type, right? So I'm saying, I'm requesting repositories back, and I'm specifying the properties that I want, right? So this you've already seen, but you can actually take this segment here and make it a fragment, okay? So this is basically the same thing. It's on repository and giving you the properties that you want back, but then you can reuse that somewhere else. So this allows you to sort of have different fragments of a query that you can reuse. So the results of this should be exactly the same. Okay. So that is a fragment. Also, there are directives. So directives are ways to, sort of like extensions to GraphQL. So there are a few built-in directives. One is if, and the other one is skip. And you can also create your own. So basically, as long as the backend knows what the directive means, you can use it. Obviously, the front end basically just sends that as part of the query string, and then it gets whatever it needs back in the back end. So you'll find a lot of services, especially ones that do integration of different REST APIs or different endpoints or different other services. Those services that provide the GraphQL feature usually have their own custom their own custom directives as well. So here, I only want to include in my results if the show language is true. Okay. So let me run this one. Okay. And show language, you see, is a Boolean variable that I sent in. So this allows you to easily parameterize the query and change the results depending on some variable. Okay. So those are directives. Again, you can create your own depending on the server implementation you're using. All right. Now another thing are mutations. So far we've talked just about querying data, and it is called GraphQL after all, like query language. But you can also use it for updating data as well. When you update data, that's called a mutation. So your API can have whatever mutations you want. And here's one called create issue. And what you do basically is you send in what this is called the input object. Okay. So these are parameters essentially. And they have the ID, the title, and the body. Let's see what happens here. So, okay. So this particular repository is, I think, the test repository I have for this project. You see I've created an issue, and there it is. Okay. And I don't remember exactly which repo it is, so I'm not going to find it right now. But there is an actual issue somewhere created on GitHub. And this is working because I'm using my own API key, which gives me access to my repos. So this is an example of a mutation. Okay, so one of the things I do want to point out is that what's nice about GraphQL is it does have, in addition to this basic idea of having a data property and then the actual data, there are other things that can be sent back. So it actually handles errors quite well. So if I do this, this is a create. Let's try another simple query. All right. So if I put, if I misspell this, right? We didn't talk about this before, but the data I get back is null, right? And then we get back an error, and these errors are always in a standard format. So we don't get an HTTP response code back. You see the response code is 200, okay? So you actually have to have code that parses the errors properly, and any client GraphQL library is going to do that for you. And usually they can also throw exceptions based on the errors they get back. But what's nice is it tells you what line it's from and it gives you an error message back. Okay. Now this also happens, so this is actually more of an error from the GitHub backend, right? But let's say I did this. Okay. Now I've got another error, and I don't even have the data null, right? Because this is happening in the GraphQL engine on the GitHub side before it even gets to their code. And it's basically saying, hey, this field name is not working. This is an undefined field on this type. Because there's a typed schema, it knows that that's not a valid property to be requested. Okay. So this is one of the nice things, this built-in error handling. If I change it back, I should get a nice happy message as well. So that's sort of the quick run through GraphQL. Let's talk about a couple more things. Okay. So we talk about schemas conceptually, right? It's a way to define the API for your GraphQL API. Let's talk about it in a little bit more detail. So it's a type safe contract between the client and the server. And again, this is one of the benefits is that it's actually type safe. Which means also that in addition to the client not being able to request properties that don't exist, the client also can't use an incorrect type or use a type in a way which is not valid. The client can only request data defined in the schema. You can't request another property. And what's different is that versioning is handled through deprecation, the same way it is with like a Java API or something, which is good and bad. It's sort of nice because you don't have to worry about V1, V2, whatever. But it also means that if you're not careful, you can end up with a whole bunch of technical debt easily. That's a whole bunch of features which need to be called at some point, and they're all just deprecated. So it's good and bad. All right, so let's take a look at the schemas. So what I have here, everyone can still see my screen, okay, right? Take that as a yes. Usually people say something when there's something wrong. Okay. All right, so what I have here is the GitHub schema. So this is actually the GitHub GraphQL schema. And you see there's lots of stuff in here. And this schema is actually 40,000 lines long. So obviously they didn't sit down and write this whole thing one day. I'm sure it's generated. But there's a lot of stuff in here. So let's start at a logical place here with query, right? And the best way to do this is to type query, okay? Okay, so the query is sort of the main entry point for doing requests to read data, right? And this is what we've been using. And we were using one very small part of this, which is the repository, right? So we were using this part of the query, but you can see there's lots of other ones too. And these are all the different queries that you can do on GitHub's API. And you see most of them are basically queries for a particular type. So, so if you look at repository, it gives us, you request a name and a string, right? And then you get back this repository. A repository is a type, okay? And you see it actually implements things. So it actually implements interfaces just like you would in Java. So it's a node, it's a package owner, a package product owner, et cetera, starable, all these different things. And the interfaces are pretty much like you would expect. So if I go here, I see starable, needs to have an ID, needs to have a Stargazer account, can have one or more. Actually, this lets you, this is a query to let you get all the Stargazers connections back. And whether or not the viewer has starred, the current viewer, okay? And you'll notice these things here. These are the comments, right? And these are just like you would document any API. They're actually useful to the user of the API. So, all right. So that's what the starable looks like. Let me go back to the repo here. Okay. Now you see there's a whole bunch of other properties here. And the ones with an exclamation point means it's required. Okay. There's collaborators, links, etc. Now, if you look at the types here, we've got a Boolean type. So there are some primitive types, Boolean, int, etc. Date time is not one of those. There is no date type built in. And even if you look at this one, this is a ref. This is not a built-in type. This is a special node that means a reference to something else. You can find all the deployments. And what's interesting about this is that if you think about the graph structure, for the any of these queries we did, we could have actually gone further and like find out all the deployments. And this would have given us all the different deployments that come back, and it would have provided this deployment connection, which then would have had the edges and nodes to find each individual deployment. So you basically can grab as much or as little of the graph as you want to. So in addition to the query, you see here, there's this app preview. So this is a custom directive that GitHub has, okay, which presumably means perhaps a preview feature. I'm not really sure. There's also, as we mentioned before, input objects, right? And input objects are what are used as input parameters for queries and mutations. So actually, if we go back to the repository, okay. Let's go back a little bit further. Repository. There we go. Okay, so if you look at some of these queries, right, assignable user, after before, trying to find one that has like an input object. I don't see one though. Okay, a lot of times this is before and after for pagination as well. So I'm not seeing an example here, but I will, if I see an input object, I'll let you know. All right, so this should give you a basic idea. There's also enums as well. Okay, so here's a repository affiliation, enum, collaborator, organization member, owner, etc. Okay, so it's a pretty rich language that you can provide, and you can really build up a pretty powerful API. So this should give you an idea about what it looks like. So I should show the mutation. Okay, so here's the mutation. So this is going to have all the operations for actually updating data in GitHub, right? And these are the examples of the input objects here. So each of these is going to provide parameters for doing the update. Okay. And they just are going to return a object back, which is going to be pretty much like you would expect. So this is what the schema looks like. Schemas can be developed in a few different ways, which we'll talk about in a minute. But let's take a look at how this looks from an Altair perspective. So we saw how we could use Altair to, basically go and execute queries, right? What you can also do when you have any tool which understands GraphQL is it can actually look at the schema itself. So you actually get the same way you would with a well-designed open API, is you can actually look at the documentation. Okay, so here's the query. These are all the fields and everything that came from the schema. So this is just the comments in the schema, right? And if I look at the repo, there's repository here. And I can drill in and I can get all the arguments and everything. So all the things that you would expect to get from a well-designed schema is right here. The other thing that the schema can do for you is help you with code completion. So if you have a tool that understands it, you can get things like this. So if I am here, I can get all of the properties that I can pick right here. And let me find a different query. All right. So if I look at repos, let me reload the documentation here. Just loading. So now I get all the properties that I can use for the repo as well. It also means that if I do this, it knows that that's not a valid property. The same thing goes like when I'm working with parameters for a query as well. So by providing schema, not only do you get type safety in terms of defining the interface between the client and server, but you also get more information that you can provide to the client and documentation out of the box, which is very handy. Okay, and then in terms of the type safety, like for example, first is a number, right? Is an int. So if I put 30 here, this is going to complain. Altair is going to complain. And then I will also get an error coming back saying it's the wrong type. Right? So this is what I mean by the type safety feature. All this happens before it even hits the backend code, really. So it's a nice feature. So that's basically what you get with schemas. You get the idea, the ability to really well define your API. All right, so let me go back over here. Oh, wrong presentation. All right. Okay. Okay, so we talked about what GraphQL is. Let's talk about some of the design approaches. So let's say you want to build a new GraphQL app, and you try and decide how to do it. First thing we need to do when you think about the schema is decide how you want to build it. So there's two basic ways you can do it. You can do schema first or code first. So with schema first, basically you build out the schema. So you actually can write out the schema using GraphQL. There are tools, plugins for IDEs to make it easy to just write out schema. And you can also use that to generate code for client and server. So there's bindings or tools to generate code for pretty much any language you're interested in. It also means that you can mock things. So as long as you have a server which is responding you can basically write like the front end because you know the contract, right? Even if you don't have the back end yet. And I was on a project where we did this, where the front end wrote a lot of stuff before we even had the back end up and running because we had a well-defined schema. So it's sort of like proto buffers a little bit, in the sense that you define your interfaces and everything up front. So it has some of the similar benefits. It seems a little less heavyweight to me, but that's just my opinion. But that's basically the idea. The other benefit of the schema first approach is if you have front end and back end teams that need to collaborate, and you don't want like the back end to drive the front end essentially. So you want the teams to work together to find what the contract is, and then they can sort of build out their features. It's useful in that scenario as well. So the code first approach is the opposite. It's basically where you just write code, and then you use a GraphQL library to generate the schema dynamically. And it can also do it as part of the build process too, depending on the tool. And this to me works better on a situation where you're okay with the backend driving the front end. You don't know what the front end is. Or you're just trying to get stuff done quicker, because obviously just writing the code is going to be quicker than spending time thinking about the schema. And then you can still tweak it dynamically over time, based on the clients using it. So, and this is a little bit easier to get up and running, and there's more tooling to support this method. So if you're using a tool set that doesn't support schema first, you're kind of stuck with this method. So, but of course you have to make this decision up front, because your whole development process is going to, change depending on this. So you don't want to have to change in the middle of your project. Okay, so we talked about the schema. We talked about all the basic queries, mutations, all the basic features. The last major feature is subscriptions. Subscriptions allow the server to push changes to the client. So as I said before, the client can say, I'm interested in changes to this particular entity, this object. Let me know when those changes occur and push them back to me. What's nice about it is that GraphQL doesn't care how it's sent. GraphQL is really not tied to HTTP. That's just how we use it most of the time. But it doesn't really care about the underlying protocol. The subscription feature usually is implemented using WebSocket, but it doesn't have to be. And I think I've even seen MQTT implementations, which is used for IoT a lot. So it really could be any messaging, framework could be used to do it. But usually you'll find WebSocket implementations. And again, the query is basically the same. The format's the same. It's just that changes are pushed dynamically. So let's take a look at this. Hold on a second. Okay, so what I've got here is for my demos, I'm using a microprofile, wrong clips. And microprofile GraphQL is just an implementation of GraphQL on top of the microprofile standard, which is used by Quarkus and Halidon and Pyara and lots of different runtimes. The subscription feature is actually experimental. So I just got an experimental version running in here. But essentially, I'll show you what it looks like. So essentially what's going to happen, I've got the server running now. And what I'm going to do is just show you what it looks like. So do a refresh here. Looks like I need to restart something here. Let me run over to the server. Focus subscriptions. Host 8080. So let me just restart it. Okay, so this is the GraphQL examples that I'm using are from Philip Kruger, who's on the Praxis team working on the GraphQL implementation. So shout out to Philip, also for all your help with my random questions. So this is an experimental repository that he has on GitHub for some of the newer features that they're adding. Now, there are other implementations that already have subscriptions built in. It's just new to this particular implementation. Let's try it now. So I'm going to guess, make a wild guess that I need to try a different server. Let's search select. I think I know what the problem is. Okay. So I think I typed something in somewhere. So let me get on here. My subscription example. Yeah, that's what I did. Okay. Now it should work. Okay. Okay. So I've got this very beautiful API here, or very beautiful page, I should say. All right, and I'm going to connect. And now I am getting data back. You see data is being pushed back to me. Okay. So I basically did a very simple GraphQL query, and now I'm getting data back. So this is the request I made, right? And I can look at the WebSocket requests. Actually, let me do it this way. There we go. All right, so you see here, it's gone to 23, etc. So these are each message that's being sent back, and see it has the same format that we're used to, where you get the data property and then you get the other properties below. Okay, and the initial request was the query. So it's just a very simple query that basically said subscription random person. And random person is just going to give me a name back randomly, basically until the connection dies. Okay, so this is a very, very simple example, but it's nice because the idea is that, you essentially do the query and then you just get data pushed back. Now, of course, you could use a client. The Altair client doesn't work with this implementation. I think it's because it's experimental. But basically what's happening here, this is just ordinary JavaScript. This is our query. And the connection is just an ordinary WebSocket. And we send our query. And then we just basically handle each message as it comes back as a normal GraphQL response. Now, if you're using a GraphQL library, it'll do all this for you. But this is basically what you do. So this is another nice feature of GraphQL, and this is something we've used in production to basically push dynamic events out to clients. Okay, so I will disconnect that. Okay, so hopefully by now you've got some idea about how all this stuff works. Let's talk about some more details. Let's talk about implementation. So let's say you're still on GraphQL, you think it's cool, and now you want to know more about how you can actually use it. So on the client side, there are lots of choices. Basically any language you want, JavaScript, Go, PHP, Java, of course, Ruby, Clojure, etc. It's all there. And there's different libraries to support it at varying degrees, excuse me, complexity. There's Apollo Elements, which is something that we're working with currently on one project, which is basically web components that wrap the Apollo API. Apollo is a company that does a lot of GraphQL stuff, and they've got a really well-known, battle-tested GraphQL client and server API, all in JavaScript, though. Their server side is running on Node. Apollo Elements wraps it nicely as an actual declarative component, which is kind of cool. So that's a nice project. Obviously, GraphQL Apollo is good. On the Java side, there is a GraphQL Java Tools project, which provides a whole bunch of features, including working with the schema first. But I should mention that pretty much everything in the Java space points back to, if you just search for GraphQL Java, you will find actually, that's not it. You'll find the GraphQL Java implementation, which of course now I can't find. Just have to spell it right. That might help. Yeah, it's actually GraphQLJava.com. I guess it's been superseded. All right. Actually, let's. Yeah, this is it. Okay, I'm just crazy. Anyways, so this is not the best. I guess it's not a very helpful site because it just has this here. But this is essentially the main library for GraphQL on Java. And it's called GraphQL Java. So it's just throwing me off the whole book thing. I'm not used to that front page. So you'll find almost every single GraphQL implementation uses this internally. So it's very low level, it's very powerful. You can also use it directly, but pretty much everything you want to use is going to be a little bit higher level. So one of those is Netflix has the DGS framework, which is the domain graph service, which also helps you federate different graphs as well. There's something called GraphQL Federation, which lets you federate lots of different graphs. That's actually from Netflix, and it works with Spring Boot. So that's a good choice if you're in Spring Boot camp. Microprofile GraphQL, which is what we're talking about here. And Spring GraphQL is pretty new, but it's available as well. So you have Spring integration. If you're using Node, you can use Apollo server as well. And there's also dozens of other implementations, but these are sort of the Java ones, and of course Apollo, since it's the most popular. So, all right, so I think I have like 5 minutes left. Is that right? Oh no, I have like no time left. Awesome. All right, well, I'm just going to do show something very quickly here. So what I've got running here, well, I will have running in a second, is another Quarkus demo, okay? And this is a set of demos for microprofile GraphQL. And what's nice about the API they provided, now again, the API you use is going to depend on what library you use. But the API they provided is really, really nice. So this is basically a GraphQL endpoint. You use normal CDI injection, and you basically say, okay, this is a query, and then I want to return the objects, and then it magically takes care of the rest of the stuff for you. And there's also the ability to, this source means that this is basically going to fire another query because a person can have scores. I can also do batching, also supports mutations with the mutation annotation, etc. And should be running now. Okay. So I can actually use my Altair client to make queries against this. Okay. So if I make a people query, I get back a normal GraphQL response, right? And this is just by basically annotating query and then making it a GraphQL API as well. And what's nice is that if you have, you get the sort of error handling features. So if I have my get people here, and then I, do this, actually, it's not going to work in the time I have, but you can get, if you have an exception being thrown, it will come back as a normal GraphQL error, which is nice. Actually, can I do this? Yeah, I don't think this. Let's see. Yeah, let's not mess with that. But it's nice that it comes back. So this is just a very quick demo of GraphQL API, GraphQL, a micro profile GraphQL. So you can use this. It's available on Quarkus, Wildfly, Halidon, I think, and some of the other micro profile limitations. But it's, again, very easy to use, and very nice. And also integrates with all the other micro profile features like metrics and things like that. All right. So I think I am about out of time. So what I'll leave you with are the GraphQL.org site. If you want to see more implementations, there's lots of stuff there. And I should mention that you'll find a lot of apps will include this GraphQL UI, which is a React UI for doing GraphQL queries. It's really easy to embed in your app for people to work with your API. So that's nice as well. Okay, and there's other tools. There's also databases that will spit out GraphQL for you if they have, especially if they have a graph backend. Those are pretty handy. And I think I'm about out of time, but I will just mention some drawbacks. All the benefits can be drawbacks depending on your organization. So, maybe you don't have time for a schema. You don't want to worry about typing. You want to have a more dynamic ability to change things. There's a lot of magic going on with the GraphQL engine, which not everybody likes. So that's something to keep in mind as well. And a lot of people like REST, and REST works well for a lot of cases. So it may not really be the best choice. Okay, so of course, REST is good in a lot of ways. So I'll leave you with resources. And again, the slides, I'll make sure they're available to JCON. So thank you very much.